NO2, and we can just use that last step to write this out. We're forming 2 molecules of NO2. So we're going to put a 2 in there because the rate at which the NO2, the concentration of this will increase twice as much as will decrease this amount. And the book is somewhat inconsistent in its use of 2's in these equations. If you're forming 2 molecules in your last step, there should be a 2, but 2 is not always in the answer key. So what I've done in the past is if you put a 2 and there should be a 2, that's great, but if you don't put it, that's okay too. So I have not taken off for this because the book has not been completely consistent in its use of that. But if you see a 2, and 2 things are being formed, you know where that comes from. So 2 times K2, that's the rate constant of that last step, and that we're talking about the concentration of O2 and the concentration of N2O2. So we're writing out just that last step there with the 2 because 2 molecules of NO2 are being formed. But we're not done with this. We can't use this because it has an intermediate term in there. And if we're going to write the rate of a reaction, the rate of product formation, we can't have any intermediates in our equation. We need to solve it in terms of products and reactants. So we need to solve for N2O2. So we need to solve for the concentration of N2O2 and substitute that into our equation. So we need to solve for it in terms of products and reactants. So we need to think about how this intermediate is formed, and we need to think about how the intermediate is decomposed, and we need to think about how this intermediate is consumed. So the net formation of N2O2 is going to be equal to the rate at which it's formed. So the rate at which it's formed. What step is it formed in, the intermediate formed in? It's in step 1 in the forward direction. So the rate at which it's formed is K1 times NO squared. So that's the forward rate of the first step. Then we need to think about the rate at which it's decomposed. What step does the intermediate decompose in? Right, the reverse of the first step. So we're going to put a minus sign here, and K minus 1 times the concentration of the intermediate. And then we also want to think about the rate at which it's consumed. And it's consumed in the second step. So that's K2 times the concentration of the intermediate times the concentration of O2. So that's the net formation. And now we can use something called the steady state approximation. And the steady